In assignment 4.3, you're going to be asked to add signed numbers. So that is adding with positives and negatives mixed together. As you go through this, first of all, your numbers will vary, and the order of problems that you might see will vary. That's okay. That's part of WAMAP. It's part of the randomization. But the basic process that we go through in actually doing these problems does remain the same. Now, in the last assignment, 4.2, you were multiplying signed numbers. In this case, we're adding them. Now, with multiplying, you really only have to do the multiplication once and then just figure out what the sign of the final answer is. With adding, it's not quite as smooth as that. You actually have to basically do the calculation over again for each different combination. So I'm going to show you a method here that for some people that have struggled with this for years, this can be a helpful way to look at it. And so this is going to be using something that's called a chipboard. And even if you have like poker chips at home or something like that for games that you have around the house or something like that, you can do this even with actual chips in your hands to actually move this stuff around. It's a great way to be able to actually do these. So the idea behind this is that we're going to use these black chips to represent positive numbers, and we're going to use these red chips to represent negative numbers. And so in this particular case, then, you notice that we start with the problem over here of 3 plus a negative 1. And so in order to be able to figure this out, then, notice I have 3 positives and 1 negative. So I'm going to start by laying out 3 positive chips and 1 negative chip. And we tend to just put them on separate lines. It makes the next part a little bit easier. All right, from there, notice that we have a pair of black and red here. Well, that's a positive 1 and a negative 1. Those cancel each other out. They would add to 0, so they cancel out. So we can go ahead and just cancel those, and notice what we're left with there. We are left with 2 black chips, which means that our answer then is a positive 2. Now let's just continue using this idea to answer the other 3 questions that we have here. The next one is 3 plus 1. Okay, you probably don't need manipulative for this one, but I just want to show you why it works here. So we have 3 positives, and we're adding 1 positive to it. Notice we have a grand total of 4 positives, which is how, using this sort of a manipulative, we can see why it equals 4. All right, the next problem is negative 3. So I'm going to grab my red chips and I'm going to put in 3 negatives plus a positive 1. And so I'm going to drop in 1 positive there. Now again, notice I have a pair here. And whenever I have a pair, they cancel each other out because that just adds to 0. So notice what I'm left with over here. I'm left with 2 negatives, which means then that my final answer for negative 3 plus 1 is negative 2. And then for the last one, we have negative 3 plus negative 1. So I'm going to have 3 negatives, and I'm going to add 1 negative to it. And so notice there's nothing that can cancel out here. There's no combinations of blacks and reds. So all I can do then is just count up how many reds do I have. And you notice that there are 4 reds, which means that my final answer then is negative 4. And so that's how we can use these chips to actually go and do some of this kind of math. Having seen this all in action, we can now apply it to a new set of problems. So this is my next problem here in WAMAP. This time it's 9s and 10s that I'm adding up, different positive and negative combinations. And so the first one is going to be 9 plus a negative 10, which means I need to have 9 positive chips and 10 negative chips. And you notice that then gives us lots of pairs. Remember, anytime I have a black and a red chip together, I can cancel those out because they just add up to 0. And so if I go down and cancel everything out, you'll notice that all I'm left with here is just 1 little red chip, which means 1 negative. And so that's going to equal negative 1. And hopefully you're also starting to see how eventually you'll probably start being able to do a lot of this in your head, which would be the eventual goal. A lot of times these manipulatives turn into things that we can envision in our brain, and then we start applying. And that's actually where I want you to be and what I want you to get to. So yeah, if you start getting to where you can just see this happening in your mind, that's a good thing. For instance, as I take a look at the next problem, I have -9 plus -10. And I might be like, I don't really feel like drawing out 9 negative chips and then 10 negative chips. I already know that I'm going to have a grand total of 9 and 10 negatives with nothing canceling, so that must be a grand total of 19 negative chips that would be sitting on my board. So, okay, I'm just going to jump straight there. That's negative 19. All right, the next one, 9 plus 10. Again, you probably don't need a manipulative for this one. That one is just a positive 19. And then for that last one, you might be envisioning it in order to be able to get it, but certainly drawing it out is a great tool. I'm going to draw out 9 different red chips here, and then I need 10 black chips because it's a positive 10. And then I just look to see, okay, how many are going to be canceling out as I go down the line. And you notice that everything cancels out except for that one little black chip that's still sitting out there, which means that my answer then is 1 positive. So just 1. And the last problem I'm going to go through here with you is this one. In this case, we have -8 plus 8 for our first one, which means that I need 8 negatives and 8 positives. And since I do have combinations of positives and negatives, yes, I can go ahead and be canceling out. But you'll notice that when I do that and cancel out all those pairs of blacks and reds, I'm not left with anything. What that means then is that our answer is 0. So -8 plus 8 is 0. All right, and then we're going to see that same pattern come out here as we continue on. The next one here, we have -8 plus -8. And so this is one of those scenarios where I'm going to have 8 negatives all across the top, and then I'm going to have 8 negatives across the bottom, and basically I'm just going to count up how many total I have, and that would be a grand total of 16 negatives, which means that -8 plus -8 is -16. Notice I could kind of start shortcutting it once I understood how to use the chips. All right, next one, 8 plus -8. So in this case, that'd be 8 positives and 8 negatives, just like we had in the very first one of this page, except that the order was different. But still, notice I'm still able to pair them up and cross out everything, which means that I'm going to be left again with 0. And for that last one, 8 plus 8, yeah, that's going to be 8 positives and 8 positives, which gives us a grand total of 16 positives. So yes, it is just going to be 16. Last thing I want to note out of this assignment is, just in case anybody's wondering about it, you'll notice how some of the negative numbers are just written as the negative number, and some of them are written with parentheses around them. What is the parentheses actually doing to it? Nothing. All that parenthesis is doing is making it a little bit easier to read, because like for that second one that I have highlighted there, if we wrote -8 plus -8, that can look a little bit funky, seeing that plus and the minus together. So whenever we have that situation, it's often common practice to put parentheses around that -8, just to say that we are adding -8 there. So that's all the parentheses are doing, and it's also why you only ever see the parentheses in these problems, at least, around that second number, and not around the first one. But again, those parentheses are not changing anything about it, mathematically speaking. They're just there to clarify.